Hello, this is Dr. Liu. In this video, I want to show you how to use a passive buzzer. So let's take a look. This is according to Arduino's processor's properties. These are from the spec sheets. So each I/O pin can support as much as 40 milliamps, but this is the maximum, the absolute maximum. You don't want to exceed these. If you do, you damage the processor permanently. And here's how we're going to calculate. We're going to use Ohm's law. Resistance equals voltage over current. So the pin is supposed to apply a 5 volt when it is set to high. So let's just say it's approximately 5 volts. And the 40 milliamps, that's the maximum current it can source, which means stay at 5 volt and supply the current. So divide the two, you get 125 ohms. So this is the minimum resistance that you should connect between the pin that you're driving something and the ground. So if you're driving a load that is uh, more resistive than this, you're okay. If you're driving a load that's less resistant than this, you are damaging the pin. So let's see, this is a passive buzzer. So how much resistance does it have? Let's take a quick look. So we have a multimeter. I'm going to configure the multimeter as an N meter. So this will just take a moment. Let's turn it off. Back to on. Okay, good. Some glaring from ceiling lights. That should solve the problem. If it's too dark, yeah, there we have some backlight. So all I have to do is to use my mini grabbers. That's for negative. The other one for positive. Okay, so we have 14 ohms. Apparently that's not enough. We're saying 125 ohms. That's the minimum. Um, that we're allowed to use our Arduino pin to drive it. So we only have 14. So what do? Well, we do have some resistors in the drawers here. Let me see what values we have. We have 10. That's not enough. 100. That's not. How about 220? Well, if you run out of 220, you can always grab some 330. So I'm just going to grab a 220. That means I'm going to use the 220 in series with a passive buzzer in order to limit the current. So here's a 220. So that, well, this time it's going to be 220 plus the 14. So the DC resistance is about 235, and that is above the 125. So I want to make some space between the value I'm using and the value that is the absolute limit, right? So that's that for the passive buzzer. So what about the active buzzer? Well, for the active buzzer, how much current does it actually use? So we can measure that. So let's reconfigure this as an ammeter. It's going to buzz because it doesn't have the right leads inserted. Okay, okay, it's good. It doesn't buzz. So let me start by getting this in here. So this is the positive voltage from the 5 volt supply, and I'll have this mini grabber over here. So let's see, can we do that? All right. So positive 5 volt, and here is the mini grabber, and I'll take the active buzzer, and I'll find the positive. I'll grab onto it. So there you go, is that, and then negative. I'll grab onto the negative lead with a mini grabber again, and I'll plug it into the power supply. The power supply is not turned on, so you won't be hearing any buzzing. Okay, let's see. It still says leads or fuse. Okay, I see. This needs to go over here. There we go. There, so now it's correct. For milliamps, this is common. So let's move the display back into the video frame. So once I turn down, the power supply is going to buzz, but at least we'll see the current, how much current is consumed by an active buzzer. So we may actually just try to mimic that, right? It's going to buzz loud. 26. Yeah, I turned it off, but there's still some residual power. All right, so 26. Let's change this value to 26. Last time I measured was 25. Could have been a different active buzzer. So 26. All right. So what are we going to use? We're going to use, for the passive, we're going to use a 220 ohm resistor. Plus is a, let's see, 14 ohm. That is the buzzer. So this is 234 ohms. And 5 over 234. That seems to be close enough to that 20 something milliamp. So let me get to my computer. 5 over 234. So that's 21.4. Okay, so 21.4 milliamps. Okay, this means we should be good. We should be, well, if the buzzers are exactly the same specs, they will be buzzing about the same loudness. So 20 milliamps compared to the active buzzer that's also buzzing at close to 20 milliamps. This should be a safe range. I think we did well choosing the 220 ohm in series with the buzzer.